Okay, good evening, good afternoon, good morning, wherever you are in the world, and welcome to our session on developing accessibility tools with Scratch and ScratchJr. We're really excited to be sharing these resources with you today, and I'm looking forward to delivering this session. I'm Neil Rickus. I work as the Scratch Education Collaborative Lead with Barefoot in the UK, and also spend a lot of my time working with trainee teachers attempting to teach them how to teach computing. And I'm joined today by...
Hello, everyone. My name's John Chippendall, and I am Director of the Barefoot Programme and Computing at School within the BCS. I spend half my week doing that, and then the other half of my week is spent teaching in a primary school, so ages 5 to 11 in Manchester, which is where I've been today. So if I look a little tired, that's because I've been battling with my year sixes this afternoon.
Thank you, John. I also have young children in the house. They're very good at leaving me to it, but I'm guarantee the one time I don't say it, we'll have little faces smiling at us. So I'm going to let John introduce the session for today.
Thanks, Neil. Yeah, so just a few session objectives to share with you for today. I'm distracted as well. Some great chat coming through and just people introduce themselves from around the world, which is absolutely fantastic. So once I finish my bit, I'm going to jump into the chat and chat with you all as well. So aims of today, we're going to develop an understanding of what Barefoot offers, all the free resources that we've got available. And we're going to hopefully sort of raise awareness of the importance of making computing accessible, examine some opportunities for children to develop their understanding of accessibility needs, and actually do some creating of accessibility tools using Scratch, and in doing so exploring a range of programming concepts. And we're going to share our programs, and then we're going to leave you with some next steps after that. So really quickly for me, what's Barefoot? If you haven't heard of it, although I can see a few of you in the chat are saying that you have from various parts of the world, which is great. Barefoot was originally established by the Department for Education in England when we changed our tech curriculum nearly 10 years ago now. In 2014, we stopped teaching what we called ICT, which was mainly teaching how to use technology, to teaching how to be creators of technology, computing with lots of lovely computer science in there, programming, understanding how networks work. And at that time, Barefoot was rolled out by our Department for Education to support teachers in making that transition. We've since been endorsed by the devolved nations across the United Kingdom. So our resources are used in Scotland, in Wales, and in Northern Ireland. And we basically provide hands-on cross-curricular computing activities for teachers to use in the classroom with their pupils, and also subject knowledge enhancement materials for the teachers themselves. Everything is developed by teachers for teachers, and it's informed by academic research. And Neil's very kindly popped the link to Barefoot Computing in the chat there. And what I have here is the computational thinking poster, and I'm going to talk through it. That was one of the main first outcomes of the Barefoot project. So everything Barefoot does is rooted in computational thinking, this idea of developing pupils as computational thinkers, which is good problem solvers. And we set out that there are 6 strands to our model of computational thinking. Logic, so logical reasoning, the opposite of just guessing, but actually thinking things through. Evaluating, making judgments against criteria. Algorithms, or more specifically, algorithmic thinking, so thinking through how a problem can be solved in a series of steps or rules. Pattern, so spotting and using similarities. There's a phrase I heard that a good computer scientist is a lazy computer scientist, and I think that is the case. If you can write a bit of code once that can be reused over and over by spotting a pattern, that's a great thing. Decomposition, breaking big problems down into smaller, more manageable problems. And abstraction, removing unnecessary detail. We also have a number of approaches on the right: tinkering, creating, debugging, persevering, collaborating. But a main output for us was this idea of computational thinking. And as I say, that's at the heart of all of the Barefoot resources. So that's a very, very short, quick. I hope that was okay, Neil. Quick introduction to barefoot and computational thinking. I'm going to hand back to you now.
Brilliant. Thank you. So today we're going to be talking a lot about inclusion and accessibility. And before we get into the main session, I briefly wanted to outline why this stuff is important. And there's people, children we teach, people we're friends with from different places all around the world that cannot access technology or find it extremely difficult to access technology. And the technology we use is often dependent on our ability to see, hear, touch, speak, and remember things. And in helping us develop our understanding of some of these barriers, we've been heavily influenced by Microsoft Design's inclusive document, which often describes how the barriers to usage can be either permanent, temporary, or situational. And I've got an image here that shows someone is having an issue actually touching a device, tapping, pinching, swiping, perhaps with a touchscreen or using a mouse. And that disability or that impairment, that might be permanent, such as someone having one arm. It might be that they have an injury, perhaps they've broken an arm and it's in a cast, or it might be related to a certain situation. So perhaps the person is a new parent and they have a baby, and at the moment they're holding that baby, and actually it's quite difficult for them to be able to use both of their hands. We've also got to think about that technology can help remove barriers, and in order to do that, we can use some of the accessibility features within software, or we can actually develop accessibility tools, and that's where our lessons focus. So we developed 3 sets of lessons. I'll explain a little bit about the focus areas in a minute, and these are for primary age pupils. There's 1 set of lessons for ages 5 to 7 years, 1 set for 7 to 9 years, and 1 set for 9 to 11 years. And they consider the accessibility needs of individuals by allowing them to experiment with accessibility tools and apps to solve a certain problem. And then following that, the children program their own accessibility tool, which enables them to develop their knowledge and understanding of inclusive technology and programming concepts. So the lessons for 5 to 7 years, they focus on using ScratchJr, and children record a sound, and they're going to produce an accessibility tool to help someone choose their food at lunchtime. For 7 to 9-year-olds, they use the text-to-speech blocks in Scratch to develop a tool to help someone communicate with their friends by typing in text to be read aloud. And for 9 to 11 years, they use machine learning for kids and their version of Scratch to use their text-to-speech blocks. And these are going to help someone communicate with their friends by speaking and then having the text displayed on the screen. While developing these resources, we're really appreciative of the support given by the Scratch Education Collaborative, particularly the funding through the Equitable Creative Coding Resources. And we felt it really important to liaise with organisations that support children with a number of accessibility needs. So we spoke to the Manchester Sensory Support Service, and one of the main things that came out from that was the importance that if someone does have one of these impairments, that actually they can develop the tools themselves. There's also a number of other organisations listed there: Access CS for All, Computing at Schools #Include Group, Microsoft Inclusive Design, UK Association for Accessible Formats, Universal Design for Learning, and the W3C Accessibility Standards. And the resources we share with you today, they're just about complete, but there's certainly some feedback to get from a number of organisations, and already some of the sessions during the conference today have made me reflect on a couple of bits that perhaps we need to make slightly better. So the lessons that we're going to look at today, and you're going to produce resources for, are those for ages 7 to 9 years, and you'll be using the text-to-speech blocks to help someone communicate with their friends by typing in text to be read aloud. The lessons initially focus on vocabulary related to inclusion and accessibility. And we spend time making sure children are familiar with these terms and what they actually mean. During the sessions, we employ a number of pedagogical approaches, and John's going to explain a little bit about what they involve.
Thanks, Neil. Yeah, we just want to talk through, get the opportunities as we go through to share some of the pedagogical approaches that we use, not just in this Barefoot resource, but underpins a number of them. Because as I said at the start, we're always keen to ensure that our approaches are research-backed. One of the most popular is that of PRIM, which was developed by Sue Sentence with support from others from Cambridge Research Group and Raspberry Pi. And it's an acronym standing for Predict, Run, Investigate, Modify, Make. And essentially it provides a structure, a sequence whereby you can introduce a concept, a programming concept, and go the whole way through the process of developing pupils' understanding of that through to pupils using it in a program. So the PRIM approach places a great emphasis and a valuable emphasis on appreciating that pupils need to learn to read code as well as just write code. So those first stages where we're predicting and running and investigating is about pupils interpreting some code that they have been provided. And you can see at the bottom bullet point there's a shift in ownership as we go through these stages from pupils being given some code initially, predicting what it might do by developing, by reading the code, running it. We often plan for it to do something slightly, not what they expected, so they can investigate why that might be, try tinkering, changing things, modifying it more purposefully, right the way through then to those stages, developing their understanding of a concept and then using that to actually make a program themselves. So yeah, that's the PRIM approach, a real popular one for me in my classroom, Neil.
Yeah, thank you, John. You explained that quite well. You did all right. Okay.
Oh, thanks. Appreciate that.
So we will just briefly mention another thing we've considered in these resources, and that's the importance of making Scratch more accessible. And within the guidance, we've highlighted some of the features in there. If you haven't seen them yet, the high contrast blocks are now available within the top left-hand corner of the Scratch window. If you click on settings and color mode, you can select those. We've also in there given guidance about different input methods, how to zoom in and out on the blocks and make them bigger, and also perhaps some of the devices accessibility tools as well, which might help pupils navigate the interface a bit more effectively. So we're going to go on now to treat you at times as if you are 7 to 9 years old, and we'd like responses in the chat for when there are questions such as these. So children, the first thing I would like you to consider, please, and put in the chat is, what challenges might a person with a speech impairment, so someone who struggles to talk perhaps, or someone who uses what we might refer to as non-standard speech, what might they find difficult, or what challenges might they be when using technology? So thoughts in the chat, please. Brilliant. So thank you, Brian, for starting us off. In the smart speakers, I'm not going to say the S word or the A word, as it may set off all of your smart speakers, but they may not be able to understand them. It might be that perhaps if you want to use dictation tools, it could be that they're not accessible to you. And it might be perhaps actually you can't phrase things in certain ways. Another thing that we're increasingly dependent on when using technology, video and voice calls. And as we've got in the chat there, actually, these can be really difficult to access. So there's lots of things that can be really challenging to use with technology, particularly as use of voice and voice recognition systems becomes more widespread. So before children actually begin to program, they develop their understanding, they experiment, or they tinker, as we might call it, with a number of different apps. We provide options for iPad, Android, excuse me, and web-based tools. And it might be that they use perhaps the natural reader to have text spoken back to them. That's a free web-based tool, and these are all in the lesson plans as well, or the text-to-speech app, which you can see there. Or there's a type of app which we've called it touch-to-speak, which is perhaps the easiest way for a child to understand it, where you can touch different images to have them read aloud. And then children have a challenge to actually find some food in a food shop, in a supermarket, and experiment with the tools and then report back how they might use that. I'm not going to ask you to tell me about that, but yeah, thank you for the response in the chat. Actually, yeah, maybe we have a role play of getting food at McDonald's. Maybe I do need to tweak this slide as well. So children then, once they've got an understanding of the various tools that are available, we then present the problem. We've got someone called Amit who is unable to speak. And just a note on the images on the slide here, we've got a boy holding a device and someone with a book. We will have images that relate more explicitly to the resource once they're released, but I just wanted to put in a few placeholders for now so you can see the style of the artwork that we often use. So we've got Amit, who's unable to speak. They've just joined a new school, and it's great to hear that they're making lots of friends, but they are finding it difficult to communicate. And within the lesson plan, we try and emphasize that this is a number of people that have a communication problem. It's not Amit who has got an issue. Everyone is finding it challenging to communicate. And Amit's friend Lisa has suggested an accessibility tool could be developed with Scratch. They've also decided that the tool should have a number of different features, and we've got an example of how the interface might look on the right here. Again, as I mentioned, this is a draft version that we certainly looking to improve the contrast on the buttons here. And we've got two buttons that can be pressed, yes or no. And we've also got a button that is entitled type. And when that is tapped or click, enables text to be entered, and then it can be read aloud. And this is what children are going to produce. Now, the PRIM methodology means that once children go on to modify and then make, they can actually tailor this as they want. But initially, we focus on the first bit. So children will begin thinking about what different things do in Scratch. We'll give them a brief reminder of the different event blocks. There's an expectation that children will have some knowledge of Scratch, but on the Barefoot site, we do have lesson plans specifically tailored to introduce children to Scratch if required, including those for learners with SEND needs as well. And we also talk about where the text-to-speech blocks are too. Often we find teachers aren't aware that we've got this more blocks section in the bottom left-hand corner. So we then go on to the first bit of PRIM. So I would like you please to pop in the chat. What do these blocks do? And I'm just going to share a specific tab so we can see if you were right. So if you pop in the chat, please, what do these blocks do? Who will be the first person to answer my prim question? Okay, so I've got say goodbye in audio. Fiona says the sprite says the words when clicked. Well, Vicky's got a really clear explanation. If you click the block, it says goodbye out loud. All right, so I'm hoping my audio is shared. So let's see if we are right.
Goodbye.
I'll show you once more.
Goodbye.
And yeah, you can give yourself a big pat on the back if you did manage to get that. So this bit of code can be found here. I'll put the link in the chat. And what we might then do with the prim methodology is that we would actually go on to enable you to modify the code and to alter it. Now, I'm not going to get you to do this bit, but I will get you to do the next modify bit, which I'll just make a little bit larger. So we can see the modified tasks here. Change the speech to say thank you. Add some text to the button. And we've got some little prompts here. And we've also got a new button that we can add as well. So the second bit to predict is, what do these blocks do? What do these blocks do? We've made a slight change here. What do these blocks do? Brilliant. Thanks for starting us off, Alvaro, there. That we click on the block and it waits for the input. And depending on the age and experience of your children, we might use the words input there. That might be a really nice opportunity to actually introduce that more technical vocabulary and user response. And thank you, Jason, for your comment too. So user will type in text and the program will read it out loud. We'd try and be really specific with what's actually going to appear on the screen. For example, would the word ask actually be displayed? Will it be in a speech bubble? Where will they type the answer? To try and really articulate all that information to make sure the children haven't just said, oh yeah, type it in it, or whatever they may say in their articulate tone. All right. Hopefully you have got that right. I'll just show you this example just to make sure that we are correct. So I'm going to tap the box here. I'll type in this text. Let's do hello everyone at the conference.
Hello everyone at the conference.
And there we go. So it's beginning to already have quite a bit of functionality there. And the modify tasks for this one enable us to experiment with the actual information displayed, changing the voice, and then adding some more speech as well, so that the computer actually says type your message, which might be a nice feature as well. So in lesson 2, the children go on to actually develop their own tool, and that's what you're going to have a go with in a minute. The lesson begins with an initial reminder of content from the previous lesson, what some of these blocks do, along with the vocabulary. And then we use a couple of different pedagogical approaches within this lesson. So I'm going to hand over to John again for a couple of minutes to explain these.
Thanks, Neil. Yes, so the first one I'd like to share is something called Parsons problems. You may or may not be familiar with these. You might have heard of these before. But essentially what you do here is you provide all of the blocks of code, the individual commands that a pupil requires to solve a problem. And it's up to the pupils to work out how to arrange those blocks to create the correct program. And you can differentiate this. You can make it trickier by putting in some blocks which aren't actually required in the solution, just to kind of throw them off center and make it a little bit trickier. But the kind of concept with this idea is that it's a bit like when you're teaching pupils to write. You sometimes want to focus on word level work, but sometimes you want to focus on the actual construct of the sentence. And we're here, it's like focusing on the construct of the sentence. We've given them the individual words. We know that these are the words, the commands you're going to need to make this program work. We're more interested in you understanding the logic and the grammar of how they're going to fit together. So it's a really powerful one, this. I use it a lot in my classroom. It's a powerful way of focusing pupils on developing their kind of logical reasoning and understanding of the logic of programming. The second one we want to highlight is the importance of design. So the model that we have within Barefoot for programming is a two-step one, where first of all you create a design and then you implement that design as code. So by having that design, there's lots of computational thinking. I might be about to be interrupted by a 3-year-old. I can hear it. I shouldn't say it, coming up the stairs. So I'm just going to carry on, but get ready, Neil. The design stage is really important for the computational thinking. This is where we're breaking down a problem, we're decomposing, we're abstracting by focusing on what's important. We're coming up with an algorithm, and then we take that design and we go and code it, and we have that two-step approach. So those are two things that we want to highlight. Have I missed anything there, Neil?
No, just to say that we sometimes will also assist pupils with that algorithm. So the program design sheet is one example that we might provide. It might be that perhaps some of the text on there is omitted as well, depending on how we're pitching the resources and what input we give them.
There's a way to scaffold it.
Yeah,
definitely.
Cool. All right, thank you. So
welcome.
Go back to the lessons, and you're going to be doing some stuff in a minute. So we have a reminder of the problem. We need this accessibility tool to be developed, and we've thought of what the tool should do. Got a button that when you press it, click it, tap it, it says out loud yes. Another one says out loud no, and then the type button, which enables text to be entered so it can be read aloud. Pupils will use their design sheet, and as I mentioned a minute ago, on this example, the algorithm is there, and we've also provided them with some blocks that are required, and then pupils can go away and begin developing their own program in Scratch. And there's the design sheet again, just to show you a bit more detail of what it looks like. So you are going to have a go at designing your own accessibility tool in Scratch. And I have got for you, he says confidently, an example where I've got the buttons available, and what you can then do is to pop in the actual bits of code. Now, unfortunately, the reason I'm hesitating slightly is that my Scratch tab has just died, so I will just talk over you for a couple more seconds. And once you get the program, you can then access it yourself. You can press remix, and that enables you to make your own copy. And then at the end, we're actually going to share that with each other in a studio. Okay, I am ready to go. So you should have at that URL, at that web address I just popped in the chat, an example program that you can then pop in your own code in order to make that program. I'm going to leave those blocks that you may or you will need to use on the screen for a few minutes, and then once you've actually started to get your teeth into developing the program, I will then pop up some ways you might want to improve your program. So just be clear, using the Scratch program that is in chat, you can remix that program to make your own version of an accessibility tool. And the functionality is outlined on the program design sheet. The blocks that you'll need are on the screen. And in around 5 minutes time, I'll put up some tasks which will enable you to modify your program. Now you can modify them in that way if you want, or you can make your own modifications. And I'm going to give you until 7 p.m. my time, which I think is 2 p.m. Eastern time, to do this. And in about 10 minutes or so, I'll share where you can share your program so we can all see what each other has made. So I'm hoping I've explained that clearly enough. Do let us know in the chat if you require any further information. Obviously, we are here for the next 15 minutes or so if you do want any further guidance. So I'm going to be quiet for a few minutes, and I'm going to go back and have a look at the chat as well. But do please ask John or myself for support if need be. So good luck with your program development, and I look forward to seeing them shared in our studio, which I'll share the link to in a minute. Okay, so I've just popped in on the screen some ways you might improve the program. Lisa, I just noticed your comment as well. Apologies if I wasn't clear at the start. Our lessons for ages 5 to 7, they use Scratch Jr. and it's a completely different set of lessons. So it's for someone with a different impairment. And on those resources, the children actually record their voice to enable someone to help somebody choose their lunch option. So you tap a sprite and it actually has the child's voice read back. So they'll be launched at the same time as these lessons in September. So I can see a few of you sharing your projects in the chat, which is great. I will share a studio where you can all put links to them in around 5 minutes time. Okay, we've got around 5 minutes of our task left, and in the next 5 minutes it'd be great if you could share your project within the Scratch studio we've created. The link is in the chat, and then once you're there, if you copy and paste the web address of your Scratch project into the box and press add by URL, and just share the tab so you can see it. So when you're there, I've already added Mark and Fiona's projects, which they popped in the chat. You copy and paste the web address of your project in here and press add by URL, and then we'll all be able to see our different examples. So I'll pop the various challenges back on the screen for you, and we'll go for another 4 minutes or so. Don't feel constrained by the enhancements listed on the screen. If you've got some better ideas, I'm sure there are better ideas out there, do feel free to add those as well. So Karen, thanks for your message. Yeah, I like how you've got the different options there. And yeah, I think the way you're doing that looks great. So if they type Y, then you say, I will get you some ice cream. I think if you join the if block up to the ask block, you'll that should work just fine. So give you 2 more minutes. Do try and share your project in the studio if you're able to. It'd be great to see a few other examples of things people have made. So last minute or so, do you keep trying to either share your projects in the chat or share them in the studio? Thank you, Avara. I've just added yours to studio as well. If you haven't used the Scratch Studio before, it's a really nice way for children to share, particularly at the end of a project, work that they've done. Okay, last 30 seconds or so. Yeah, these projects are looking really nice. So thank you everyone for popping them in there. Oh, and Shannon, just a note on your project. I don't think you've shared it. If you just click the share project button at the top there, it should enable us to be able to see it. Okay, we're at a point where we do need to crack on to make sure we finish on time. So thank you for taking the time to share those projects. Apologies if you can hear a couple of motorbikes in the background. I'll just put the link to the studio into the chat again in case you do want to look at some of those projects in a little bit. So you have shared your work, which is great, and thank you so much for taking the time to actually have a go at those activities. And in order to now get these into the classroom, we're in the process of getting some feedback from the Scratch Education Collaborative team, along with some work in schools. And then we're looking forward to launching these along with some live lessons and some relevant CPD materials in September, barefootcomputing.org. So there's a couple of bits to consider before we leave. The first one, which I haven't popped on the slide, is firstly, how did you actually find developing those resources? Was it something that you found quite straightforward to do? Were there any bits you found challenging? Were there any bits you thought, actually, oh yeah, that's quite an interesting way of doing it? So firstly, your thoughts on actually how you found undertaking that task in the chat would be great, please. If John, perhaps you could summarize just a couple of these, perhaps.
Sorry, Neil, did you just say something to me? I was just responding in the chat there. Somebody's asking who, Mark was asking who 10 Maker Space is. And I think I'm right in saying that 10 Maker Space is the Scratch account of one of our colleagues. It is. That's Fiona, who's joined us, who's actually the Barefoot coordinator in Northern Ireland, Mark. So, oh, and she's responded. She's fessed up. That's me. Yeah. So, and some really interesting comments from Alvaro, liking the Parsons problem approach to scaffolding learning. Definitely going to use that. Yeah, can't recommend that one enough. Also, as well, Neil, you'll probably know better than I do on this as well. Just in terms of being able to deploy those blocks. You can kind of make a Scratch file in advance and just get everyone to open it, and then they've got their blocks ready to go. That's a way to do it, isn't it?
Yeah, and on the resources, once they're released, there'll be the version that you use today, but there will also be a version with those blocks in place simply to rearrange as well.
Yeah, yeah. And somebody else is saying here, Biana, found it really helpful when the blocks were previewed before making. So I think you're referring there to sort of the Prim approach, I think. I would certainly say, please do go away and read up a bit more about Prim. In fact, we've got an article on the Barefoot website all about Prim, going into a bit more information.
I'll find it for you.
Yeah, fab. Please do, Neil. So, in fact, was it Neil? Was it yourself that wrote it? I don't think it was. I think it was Ben, maybe Ben Davies, who's another one of our teacher authors. So what he started doing was primming our resources. So taking that methodology and then applying it to some resources that we'd already created. Thanks, Neil. So you've popped the response in there. Yeah, Vicky's saying Prim is great. It is. It is. It is. It's a really solid structure to enable you to focus on a concept right away from introducing it, developing that understanding and applying it.
Yeah, that's great. Thank you. So the second question then, which is the top one on the side then, is sort of partly linked to what we've just been discussing, but any main takeaways? Is it that you think, actually, I'm going to start giving pupils a few blocks to rearrange, or that I'm going to ensure we talk more about what certain blocks are doing before we actually get going? So main takeaway from today's session. And just while you're thinking about that, obviously these lessons they're nearly there. But we're always open to constructive criticism, or obviously things you like as well, if you want to help us blow our own trumpets. But any feedback on the lessons as well, things that it might be you thought certain tweaks were needed. For example, I know, as I mentioned at the start, actually, I've realised the contrast on those buttons between the text and the colour of the block isn't good enough at the minute. So that's something that certainly need to change before we release these. And thank you, Mark, for sharing.
The link that Mark's put in there, I've just been on it on another tab. It's excellent. It's got a link through to all of Sue and Jane's papers, the academic papers detailing.
Yeah, nice. So a quick look in the studio as well. Some really nice bits. So thank you for everyone who's put their work into there.
That's great to hear, Shannon, as well. So Shannon's saying that she's brand new to Scratch, signed up for an account today and was able to follow along well. So thank you.
That's really nice to hear, Shannon. Thank you. Brilliant. Okay, so let's give you another minute or so to pop your thoughts into the chat. Just a couple of bits while we're getting those. We've got our Twitter handles on there should you want to tweet nice things to us, and the Barefoot Computing website is on the bottom there as well. So I think we're just about there. Those resources said will be available in September. There'll be separate lessons for ages 5 to 7 years with Scratch Junior, and then 7 to 9 and 9 to 11 with Scratch. Thank you very much for taking the time to develop your programs, and thank you in particular for all your responses in the chat. You've made our job very easy by responding at the right time and actually doing what we've asked. So thank you for that. John, anything to add?
No, just to say, echo what you said. Thanks to everyone. There's some really nice comments coming in on the Scratch in the chat here. And Neil, thanks to you for all of your efforts over the last few months in developing these resources and working with the Scratch Education Collaborative. I know it's been a really informative for us, Barefoot, to be part of that and to tap into everyone's knowledge there. So thank you for that.
Definitely. Okay, so I'll give the chat 30 more seconds, as everything that is coming in is really nice. If it starts getting negative, I'll end the call, and we'll go from there. But yeah, just give it another 20-30 seconds or so. People do want to.
Fiona said it's a great way to get some user experience feedback from around the world. It is a unique global audience that have joined us this evening and that are a part of the Scratch conference, which is amazing.
Yeah, it's lovely. It's, I think, at the start, the range of people that have come from around the world.
Fiona's just saying, finally, do you have a studio link you can drop into?
Yeah, I'll pop it in the chat again for you, Fiona, which is just there. Okay, so I think we will leave it there. Thanks again. Thank you, John. Thank you to our moderator, Margaret. Thank you to Chris for all of your technical support and giving us a nudge as required. And that's great. So thanks again. Goodbye.